Okay, let's dive right in. We're going to be talking about a technology that is, and I'm not exaggerating here, completely changing how we build and measure pretty much everything. It's called Dimensional X-ray Computed Tomography, or dXCT for short. And you can think of it as a ruler that can literally see through solid objects with mind-blowing precision. So, this really gets to the heart of a huge problem in modern manufacturing. I mean, think about something like a jet engine turbine blade, or maybe a high-tech medical implant. These things are packed with super complex internal channels and structures, and they're absolutely critical to how they work. But they're totally hidden. So how in the world do you make sure they're built perfectly? Sure, if you've got a simple block, a pair of calipers will do the trick, no problem. But for the incredibly intricate parts we're designing and 3D printing today, those old tools are, well, they're basically useless. You just can't measure something you can't get to. This is what we call the hidden measurement problem, and it's been a massive roadblock for innovation. So how are we going to solve this? Well, here's the plan for this explainer. We're going to start with the problem itself. Then we'll get into the huge shift in thinking that cracked the code. We'll look at the rules that make this all so precise, the tough challenges that scientists are still tackling, and then, the best part, we'll see the incredible real-world impact this is having right now. You know, as our manufacturing gets more and more sophisticated, I'm talking about things like additive manufacturing or 3D printing, our ability to actually check our work, to do quality control, has had a hard time keeping up. It's a real paradox. The more complex the part, the harder it is to be 100% sure it's perfect. And that brings us to the solution. And it's not just a fancier tool. It's a totally new way of thinking about inspection. It's about making the leap from just looking at a picture to taking a true, reliable, quantifiable measurement. This quote just nails it. A normal X-ray lets you see inside something, right? It's qualitative. But dXCT is all about knowing exactly. It's really the difference between a cool photograph of a building and the actual architect's blueprint, with every single measurement verified down to the millimeter. So here's the official definition. The two phrases you really need to hear are traceable metrology tool and documented uncertainty. This tells you it's not just making a pretty picture. It's a serious scientific instrument giving you numbers you can bank on. And that documented uncertainty part, that means the machine actually tells you how certain it is. You know, plus or minus a few millionths of a meter. It's incredible. And this table really spells it out. A conventional X-ray gives you an image to look at. Dimensional XCT gives you a measurement to trust. Its entire purpose is metrology. That's the science of measurement. And it all hinges on super rigorous calibration that ties every single measurement back to international standards. So, what is the secret sauce here? How does an X-ray image magically become a precision ruler? Well, it's not magic. It all comes down to following a really strict set of rules, the fundamental principles of metrology. Okay, so the first and most important rule is something called traceability. And the best way to think about it is like an unbroken chain. It all starts with the official international definition of the meter. From there, national labs create these hyper-accurate objects, like a perfect sphere. Then those objects are used to calibrate the dXCT machine. This chain guarantees that every single measurement, anywhere in the world, is linked back to that one single standard. And that's the whole point, right? Traceability is what makes our modern global world work. A supplier in Tokyo can make a part, measure it with their traceable system, and a manufacturer in London knows with absolute certainty that it's going to fit perfectly. But wait, there's another crucial rule of precision. Because here's the thing. No measurement is ever 100% perfect. There's always a tiny, tiny bit of doubt. Scientists call this uncertainty. And the real key is knowing exactly how much uncertainty you're dealing with. And with dXCT, figuring out that uncertainty is just ridiculously complex. You have dozens of little things that can introduce tiny errors, everything from the stability of the X-ray beam to a microscopic change in the temperature of the part to the software that's actually building the 3D model. A true dXCT system has to account for all of it. Now, as amazing as this is, the technology isn't magic. Turning X-rays into measurements that are accurate to fractions of a human hair, well, that runs into some serious physical challenges. But the innovations that are being developed to beat those challenges are just as impressive. The three biggest hurdles are all rooted in physics. You've got something called beam hardening, which can distort the data. Then there's scattering. Think of it like trying to take a picture in a really foggy room. The light bounces everywhere and blurs the image. And finally, even the tiniest vibrations or temperature shifts in the room can throw off the system's mechanics. But this is where the story gets really cool.
To fight back against the fundamental laws of physics, engineers are bringing out the big guns, powerful artificial intelligence, and some incredibly sophisticated software. So the traditional ways of building the 3D model are fast, but they can let all those little physical errors creep in. AI-powered reconstruction, though, is a total game changer. It's trained on thousands of scans, so it actually learns to tell the difference between a real feature on the part and just noise from something like scattering. It essentially cleans up the data, revealing the part's true shape with just stunning accuracy.
Okay, so let's get to the payoff. All of this incredible science isn't just stuck in a lab somewhere. It is already out in the real world being used to build safer, better, and more advanced products that you might even use every day.
Take aerospace. With dXCT, you can look deep inside a complex turbine blade to make sure the internal cooling channels, which are absolutely vital for engine safety, are perfectly formed. And you can do it without ever having to cut that expensive blade open.
And for 3D printing, it's nothing short of revolutionary. A custom 3D printed hip implant can be scanned to guarantee that its complex internal structure, the part designed to help bone grow into it, matches the original digital design with absolute verifiable precision.
It's also a huge deal for medical devices. We can now see the invisible pathways inside things like auto-injectors or insulin pumps. We can make sure they're going to work flawlessly when someone's life is literally on the line. And it's transforming the car industry too. Engineers can inspect an entire assembly, like a fuel injector, all at once without taking it apart. They can measure how dozens of internal pieces fit together, spotting tiny problems long before that car ever leaves the factory. So, to wrap this all up, what are the big things to remember? First, dXCT is not a camera, it's a ruler, a really, really precise one. Second, its real power comes from that unbroken chain of traceability back to global standards. Third, its unique gift is being able to measure the hidden stuff without destroying the part. And finally, AI and amazing software are pushing this tech past its old physical limits. And that leaves us with a pretty cool thought to end on. For most of human history, what we could build has always been limited by what we could measure. So now that we can finally measure almost anything, anywhere, with near-perfect accuracy, what incredible new things are we going to build next?